Imagine a building, not one of glass and steel from the 21st century, but one crafted by hands thousands of years ago. Imagine that building standing tall, year after year, defying everything thrown its way. The relentless hammer of time, the biting winds of the desert, the furious shake of the earth. How is it possible? Look at the modern world around us. Our buildings, monuments, and bridges, masterpieces of contemporary engineering, often require extensive, costly maintenance to survive just a few decades. Yet structures like the pyramids of Giza, the Roman Colosseum, or Machu Picchu still dominate their skylines, centuries and millennia after their builders laid the very last stone. This isn't just a question of history, it's a fundamental engineering mystery. How did civilizations without steel girders, without computer models, and without powerful cranes manage to create structures that possess a level of durability that often exceeds our own? It's a riddle whispered by the stone, a secret hidden within the mortar, an act of defiance against the endless march of decay. We often look at ancient ruins and see only destruction. We see the crumbled walls, the missing facades, the empty spaces. But what we should be focusing on is what remains. The incredible, unwavering endurance of those core structures that simply refuse to surrender to the sands of time. This is not about accidental survival. This is about intentional resilience. In this journey, we are going to expose the mind-bending reality that civilizations thousands of years ago built structures more robust, more sustainable, and in many ways, more resilient than anything we construct today. We will peel back the layers of history to uncover the forgotten genius, the seismic-proof foundations, the miracle materials that self-heal, and the architectural geometry that laughs in the face of gravity. Prepare to have your perception of history and human ingenuity completely revolutionized. This is Surviving the Sands of Time, Resilient Ancient Structures. Get ready to uncover the unbelievable engineering secrets that allowed these ancient marvels to literally last forever. We marveled at their survival, but to truly understand the genius of the ancients, we must first confront the sheer scale of the challenges they overcame. Imagine a colossal siege that never ends, an enemy force that never tires, attacking day and night for thousands of years. This is the truth of time. The greatest architectural feats were not defeated by rival armies, but by the slow, unseen, relentless assault of nature itself. We call these forces the unseen enemies. And their primary weapon is time. Water. It is the giver of life and the ultimate destroyer of stone. The first, most pervasive attacker is rain. It seeps into every joint, every fissure, every tiny crack. Over centuries, this process is known as freeze-thaw cycling, perhaps the most insidious form of decay. As temperatures drop below zero, the trapped water expands by almost 10%. This expansion acts like a tiny, relentless wedge, gradually prying apart the mortar, cracking the stone, and weakening the entire structure from the inside out. It is a slow-motion explosion, repeated hundreds of thousands of times. But the assault doesn't stop there. Groundwater rises through capillary action, pulling destructive salts from the soil directly into the porous building materials. When this water evaporates, the salt crystallizes within the structure, exerting pressure that literally turns solid rock into dust. The Romans, masters of drainage, knew that if you couldn't beat the water, your structure was doomed. But even their systems decay, leaving their descendants to fight a losing battle against relentless moisture. We think of earthquakes as sudden, dramatic events, a terrifying 15 seconds of shaking. But the seismic threat to ancient structures is far more complex. These titans often sit on active fault lines, from the Mediterranean's collision zones to the Pacific Ring of Fire, where Inca fortresses stand. The single massive quake is a threat, yes, but equally destructive is the constant, low-level vibration, the microtremors. These continuous, subtle shakes induce structural fatigue. Every tremor, no matter how small, slightly stresses and flexes the material. Over 2,000 years, this cumulative stress on rigid heavy masonry can lead to the formation of invisible internal fractures that are just waiting for the next big shock to complete the collapse. A modern concrete structure might handle this stress for a century. An ancient one must handle it for 20 centuries. The fact that the temples of Greece and the citadels of Peru still stand is not just miraculous, it's a profound statement on their forgotten anti-seismic engineering. Consider the desert monuments, the pyramids, Petra. They face the wind, carrying the abrasive tool we call the sands of time. This is nature's sandblasting, a constant, grinding process that slowly strips away inscriptions, smooths out carvings, and erodes the protective outer layers of stone, exposing softer material beneath. Simultaneously, the sun and temperature cycles wage war. Thermal stress is an invisible hammer. Stone and masonry expand during the blazing heat of the day and contract sharply during the cold nights. This continuous expansion and contraction, minute by minute, day after day, year after year, puts incredible tension on the joints and bonds, eventually creating thermal cracks that allow the water and wind enemies to gain a deadly foothold. It is a war of attrition where every dawn and every dusk is an attack. The earth fights to reclaim what was taken. The seeds of trees and bushes find purchase in the tiny cracks created by the freeze-thaw cycle. Once established, their root systems act as immensely powerful hydraulic jacks, splitting apart foundations and crushing walls. Look at the temples of Angkor Wat, where massive tree roots seem to swallow the stonework whole. Then there are the chemical pollutants, from the natural, like bird guano and mineral deposits, to the modern scourge of industrial air pollution. Acid rain, a product of our own industrial age, actively dissolves the calcium carbonate in marble and limestone, slowly turning intricate sculptures and protective facades into a coarse, eroded shell. The air we breathe is now accelerating the destruction of monuments that survived empires. As devastating as nature is, history reveals that the single greatest threat to ancient structures is the human factor. Not just the wars and sieges, though they are terrible, but the slow, methodical dismantling for raw materials. The Colosseum was plundered for 2 centuries, its stone used to build Renaissance palaces and churches. The Great Wall was cannibalized by local villagers for housing materials. In the modern era, the threat is often neglect, vandalism, and unchecked development. Urban sprawl encroaches, climate change shifts coastlines and accelerates weathering, and mass tourism, while necessary for funding, ironically speeds up wear and tear. Yet despite this constant, four-pronged assault by nature and the final devastating blow by human hands, these titans endure. They stand as battered, beautiful, unyielding champions. We are about to reveal the forgotten genius, the secret weapons they used to win a war that should have been unwinnable. We have faced the enemies, the freezing expansion of water, the relentless grind of wind, the terrifying fatigue of seismic energy. The question is no longer how are they still standing, but what did they know that we have forgotten? Forget everything you think you know about ancient technology. We're about to expose the mind-bending reality that these civilizations built structures more robust, more inherently resilient than anything we often construct today. Their survival was not a fluke, it was a feature. It was intentional resilience built into the very DNA of the structure. Modern engineers believe in rigidity. Lock the structure down, make it strong enough to resist the force. The ancients often took the opposite approach. They built to dance. Their first secret weapon was a profound understanding of seismic activity. Consider the dry stone masonry of the Inca at Machu Picchu. Their walls are famous for their flawless interlocking stones, cut so precisely that you cannot slide a credit card between them. But this precision isn't about stiffness, it's about flexibility. When an earthquake strikes, these stones don't shatter. Instead, they momentarily unlock, absorbing the kinetic energy, subtly shifting, and critically, they settle back into their original, stable configuration once the tremor passes. They bend without breaking. We see this same principle in completely different cultures. Look at the ancient Japanese pagodas. These wooden towers, built over 1,000 years ago, are remarkably earthquake-resistant, not because they are stiff, but because they are flexible. They incorporate a central pillar, or shinbashira, that acts like a counterweight or pendulum, decoupling the structure's movement from the ground's tremor. The floors sway independently, neutralizing the destructive energy. The lesson here is clear. When the earth shakes, the structures that survive are the ones that are designed to move. Remember, water was a silent killer? The genius of the ancients was transforming this enemy into a managed resource. Take the Roman aqueducts. These aren't just channels. They are masterworks of civil engineering designed to maintain a perfect, gradual slope for dozens of miles, preventing stagnation and controlling flow. Their arches weren't just decorative. They provided structural relief, allowing water to pass around the structure, rather than letting it accumulate and degrade the foundations. Or consider the city of Petra. Carved into sandstone, the buildings themselves should have been destroyed by flash floods. Yet the Nabateans engineered a system of sophisticated dams, cisterns, and channels that diverted torrential floodwaters around the city and stored them for dry seasons. They built for the worst-case scenario. Every single aspect, from the sloping of a roof to the alignment of a street, was a calculated attempt to shed water and keep the foundations dry. The health of the structure depended entirely on its ability to manage moisture. They lacked calculators, but they understood geometry better than almost anyone. Their third secret was the perfect selection of shape. The arch, the dome, and the pyramid are not just aesthetically pleasing, they are inherently superior load-bearing shapes. The arch, for example. Unlike a straight lintel that must bear all the weight directly in the center, the arch efficiently converts downward vertical forces into outward lateral thrusts, distributing the stress across the curve and down to the sturdy side abutments. This dramatically reduces the tension stress that causes modern materials to fail. The Parthenon's dome, one of the single greatest feats of ancient architecture, took this to its extreme. A perfect hemisphere that has stood for nearly 2 millennia because the geometry allows the load to be channeled seamlessly downwards. They understood that the perfect circle and the perfect triangle are inherently stronger than any manufactured material. This knowledge wasn't pulled from a textbook. It was forged through generations of observation and failure. These principles were developed through a relentless trial and error process. When a wall collapsed during an earthquake, they studied why it collapsed, adapted the design, and rebuilt it better. There was no instantaneous structural analysis software, only inherited wisdom and meticulous craftsmanship. Every stone mason, every laborer, every architect was part of a living knowledge chain that perfected techniques like staggering joints, using massive foundational stones to prevent settlement, and incorporating natural expansion joints. They passed down trade secrets that prioritized longevity over speed and mass over minimalist design. This commitment to craft resulted in an unwavering spirit, a structural integrity that came from a deep, almost spiritual understanding of the forces they were trying to master. The result of this genius? Structures that are often still the most energy efficient, the most climate appropriate, and the most structurally honest buildings in their regions. We've seen the principles: dynamic flexibility, hydrological mastery, and perfect geometry. But that's only half the story. Their resilience also lies in their materials. In the next section, we dive into the secret chemistry, the ancient miracle materials that literally gave these structures the power to self-heal and endure where our modern chemistry fails. We've seen their architectural genius, their mastery of seismic movement and fluid dynamics, but the most profound secret to their enduring legacy lies not in the shape of the structure, but in the very dust they used to bind it. They didn't just build with stone, they built with a forgotten chemistry, materials that somehow gained strength over millennia, that healed themselves, and that laughed in the face of saltwater corrosion. We call these the miracle materials, and at the top of the list sits the legendary invention of the Roman Empire, opus cementitium, or Roman concrete. For centuries, modern engineers dismissed Roman concrete as primitive. They used lime and rock, simple ingredients. But the Romans had a secret ingredient that is baffling scientists even today: volcanic ash, or pozzolana. When mixed with lime and seawater, this ash undergoes a unique chemical reaction that continues long after the concrete has hardened. Modern concrete, the stuff we use in our skyscrapers and bridges, is strong but rigid. It fails when water seeps into microcracks, causing rebar to rust and the concrete to eventually spall or flake off. But Roman concrete is different. When seawater penetrates a tiny crack, the pozzolana and lime reactivate, forming a calcium aluminium silicate hydrate compound, a dense mineral phase that actually grows and fills the gap. This material is literally self-healing. Imagine a harbor wall standing for 2,000 years, continually battered by the corrosive, salty ocean. Modern concrete structures last maybe a century in that environment before needing major repairs. Yet Roman jetties and breakwaters are still intact. Their material wasn't designed to merely resist decay, it was designed to improve with age. It turned its greatest enemy, seawater, into its greatest ally. This is not just construction. It's an active, long-term geological process captured in a building material. Now, let's pivot from the Roman sophisticated chemistry to the sheer power of human craftsmanship. The Inca of South America mastered a construction method that required no mortar, no cement, and no chemical reaction whatsoever: dry stone masonry. Their walls, such as those at Machu Picchu or Ollantaytambo, look like giant, flawless jigsaw puzzles. The builders didn't just fit the stones, they carved them to interlock in 3 dimensions, creating a tight bond that didn't rely on binding agents. This craftsmanship served 2 monumental purposes. First, it provided unmatched structural stability against lateral forces. It's nearly impossible to push a stone out because it's physically locked in place by its neighbors. Second, and crucially for their earthquake-prone region, it gave the wall a dynamic flexibility. The joints were so tight, yet so complexly angled that when the ground shook, the stones could rub against each other, absorbing the shock like structural cushioning, without dislodging. As soon as the tremor subsided, the sheer weight of the stones settled them back into their original stable position. This wasn't merely building, it was stone tailoring. This method prioritized precision and patience over speed and cheap materials, a lesson we seem to have entirely forgotten. The materials were only as good as the builders who used them. Ancient construction mastery extended to simple, elegant techniques that guaranteed longevity. One key concept was mass and minimal joints. The Egyptians, for instance, used massive stones, weighing tons, at the base of their structures. This sheer mass prevented shifting and sinking into the foundation, countering the forces of settlement and uplift. Fewer stones meant fewer joints, and fewer joints meant fewer entry points for water and decay. Another technique was staggering joints, a simple but vital technique of overlapping successive layers of stone or brick. This distributes the load evenly and prevents a single, continuous line of weakness from running through the structure, which is often what causes walls to buckle or collapse. It's an easy concept, but flawlessly executed on a monumental scale over thousands of miles, such as sections of the Great Wall of China. And finally, the use of specialized foundations. Many ancient builders placed their structures on thick, deep layers of crushed stone or even charcoal, which help drain water away from the base, preventing the capillary action that destroys walls from below. They were building robust, dry platforms long before they even started laying the first structural stone. What these miracle materials and master techniques reveal is a fundamental difference in philosophy. We build fast, cheap, and disposable, relying on complex maintenance schedules to sustain the structure. They built slow, meticulously, and with a vision for eternity. They understood that the upfront investment in quality materials, whether it was self-healing concrete or flawlessly carved stone, would yield dividends for 2,000 years. The Roman chemist, the Inca stonemason, the Egyptian pyramid builder. They were not just building buildings, they were engineering time capsules. We've seen how they built. Now let's apply these lessons to the structures that have survived the ultimate test: millennia of existence. It's time for the case studies. We have uncovered the blueprints, the genius of dynamic engineering, and the secret chemistry of self-healing materials. Now it is time to witness these principles in action. For these structures are not just enduring. They are champions that have stood against the seemingly insurmountable odds of time, war, and the earth itself. They are our ultimate case studies in resilience. Our first stop is Rome, and a building so architecturally perfect it feels extraterrestrial. The Parthenon. For nearly 2,000 years, its massive dome, the largest unsupported concrete dome in the world, has remained essentially uncracked. Why? It's the perfect synergy of geometry and the miracle material we just discussed. Remember Roman concrete? The Parthenon is the ultimate showcase. As the dome rises towards the oculus, the builders drastically change the mix of the concrete. At the base, where the load is greatest, they used heavy aggregate like basalt and ceramic bricks. But as they neared the top, they transitioned to much lighter materials, primarily volcanic pumice and tufa. This reduced the overall load on the dome by hundreds of tons, minimizing tensile stress. Furthermore, the design incorporates a crucial engineering trick: the massive central opening, the oculus. Many believe this opening is merely for light, but structurally, it serves as a gigantic stress relief joint. It removes the heaviest, most complicated section of the dome, allowing the remaining structure to settle and withstand stresses without catastrophic failure. It is a masterpiece of material science and calculated weight reduction that has defeated gravity and the ravages of time for 20 centuries. Next, we travel to the Andes Mountains, one of the most seismically active regions on Earth. The Inca city of Machu Picchu sits directly above two major fault lines. This city is subjected to major earthquakes several times a decade. Logically, it should have been rubble centuries ago. Yet its core structures remain perfectly aligned. The secret, as we briefly explored, is the mastery of dry stone masonry, applied with an absolute commitment to dynamic flexibility. The stones are carved with concave and convex curves, like structural puzzle pieces, that lock them together but allow them to move slightly under the force of a tremor. Imagine a boxer rolling with a punch instead of trying to block it rigidly. When a quake hits, the walls gently shift, dancing with the earth's rhythm. Once the shaking stops, the massive, perfectly fitted stones settle back into position. They didn't anchor the city to the ground. They engineered it to be a fluid, living part of the landscape. Their genius was recognizing that strength comes not from rigidity, but from the ability to adapt. Our final case study stretches across thousands of miles of incredibly varied terrain. The Great Wall of China. The wall is not a single structure, but a monumental series of structures, and its longevity lies in the builder's adaptability. Where rock was abundant, they built with stone. Where the terrain was flat and loess soil was common, they used rammed earth, a simple, dense material that cures and hardens over time. In other sections, they used baked brick, a high-tech, industrialized material for its time. They didn't have one magic formula. They had 1,000, adapting their materials and techniques to the local geology. Furthermore, the wall's construction often incorporated specialized lime mortars derived from sticky rice, a brilliant bioadditive that provided superior tensile strength and water resistance. The result is that some remote, ancient sections, though neglected for centuries, remain remarkably intact, demonstrating that local, pragmatic engineering triumphs over monolithic, one-size-fits-all designs. From the self-healing dome of Rome to the earthquake-dancing walls of the Andes, these structures serve as living monuments to human ingenuity. They show us that with foresight, meticulous craftsmanship, and respect for the natural environment, we can indeed build something that endures. But what do these lessons mean for our future? That is what we explore next, as we look at how the forgotten wisdom of the ancients is now providing the blueprint for building tomorrow. We started by asking a profound question: how do they still stand? We now know the answer. Through a commitment to quality, a profound understanding of natural forces, and the ingenuity to make materials that last. But these lessons are not just footnotes in history books. They are a blueprint for our future. In a world facing climate change, resource scarcity, and the need for truly sustainable solutions, contemporary architects and engineers are undergoing a massive reawakening. Scientists are actively studying Roman concrete, trying to replicate its self-healing capabilities to create modern infrastructure that requires less maintenance and lasts centuries, not decades. Urban planners are looking at the hydrological systems of Petra, realizing that water management and deflection are far more sustainable than fighting the water with pumps and dams. And in seismically active zones, we are returning to the ancient concept of flexibility, designing buildings with base isolation systems that allow them to dance with the earthquake, just like the walls of Machu Picchu. The enduring legacy of these structures is not simply their physical presence, it is their philosophical challenge to us. The ancients built slow, they built meticulously, and they built with a vision of permanence. They left behind more than just ruins. They left testaments to human perseverance and a deep, almost sacred respect for materials and nature. As you look at the world around you, we encourage you to appreciate the history and the genius embedded in every surviving arch, wall, and dome. Let these resilient titans be our teachers. Let us apply these timeless principles to build a future that also defies the sands of time. As we've seen, the precision of pre-Egyptian technology challenges everything we thought we knew about our ancestors' capabilities. But these impossible feats weren't just isolated anomalies. They laid the groundwork for a legacy of engineering marvels that followed. To understand how this ancient mastery evolved, we must travel forward in time to an era that perfected the art of durability. How did the structures of the ancient world survive for millennia, while our modern concrete crumbles in decades? Let's dive into the 2,000-year-old secret of why ancient buildings never collapse. We like to think of human history as a straight, ascending line. We started with sharpened sticks, moved to bronze, then iron, and eventually the silicon chip. It's a clean, logical, and comfortable story. But what if that story is missing its most important chapters? What if the timeline we've been taught is actually full of holes? When you look at ancient Egypt, you're told you're looking at the pinnacle of the Bronze Age. But if you look closer, under the sand, deep in the bedrock, or inside the very blocks of the Great Pyramid, you start to find things that simply shouldn't be there. We're not talking about gold jewelry or beautiful art. We're talking about industrial-grade engineering. Granite sliced with the precision of a laser. 100-ton boxes finished to a flatness within a few microns. That's less than the width of a human hair. And drill holes in some of the hardest stone on Earth that suggest a speed and power we only achieved in the modern era. The problem isn't just that these things are impressive. The problem is that they are mathematically impossible for the tools of the time. According to the history books, these people only had copper saws, stone hammers, and sand. But try cutting solid rose granite with a piece of copper and see how far you get. Hint, you won't even leave a scratch. Today, we're stepping away from the myths and the mummies to look at the technological ghost. Physical evidence of a precursor civilization that mastered the material world long before the first pharaoh even took the throne. These are 9 pre-Egyptian technologies that should not exist. And once you see them, you can never look at a pyramid the same way again. In 1936, during an excavation at the edge of the Saqqara Plateau, a British archaeologist named Walter Emery stumbled upon something that would challenge our entire understanding of ancient history. He was clearing out the tomb of a high-ranking official named Prince Sabu, dating back to the First Dynasty, roughly 5,000 years ago. Among the usual funeral offerings, Emery found a shattered object made of a dark, fragile stone called schist. When he painstakingly pieced it back together, the result wasn't a vase or a plate. It was a 3-lobed circular disc with a central hub, looking disturbingly like a modern boat propeller or a centrifugal pump. Now take a second to look at this shape. It is incredibly sophisticated. It features 3 thin, curved lobes that fold inward toward a central cylinder. The geometry is so complex that even today, with our 3D printers and CNC machines, carving this out of a single block of stone would be a nightmare. But here's the kicker. Schist is a metamorphic rock that is notoriously difficult to work with. It's composed of layers that flake and chip easily. To carve these paper-thin aerodynamic curves into such a brittle material without breaking it requires a level of mastery over stone that we simply don't attribute to the First Dynasty. The official explanation for mainstream Egyptology is that it's a ritual vase or perhaps an ornamental lampstand. But let's be honest, does that look like a vase to you? If you put liquid in it, it would spill out of the sides. If you put a candle on it, why create such a complex, balanced geometry? When engineers look at the Sabu disk, they don't see a decorative plate, they see fluid dynamics. In recent years, researchers have created 3D printed replicas of this disk and put them to the test. When you spin this shape in water, it creates a powerful centrifugal vortex. It functions almost exactly like a modern impeller, a part used in pumps to move liquid or air. It is perfectly balanced, designed for high-speed rotation. But here is the massive contradiction that keeps historians awake at night. The wheel wasn't supposed to have been introduced to Egypt for another 1,000 years after Prince Sabu died. And yet, here we have a highly advanced, balanced, aerodynamic wheel found in one of the oldest tombs in Saqqara. If this was part of a machine, where is the rest of it? Or, perhaps more intriguingly, is the Sabu disk a stone copy of something much older? Imagine a primitive person finding a metal propeller from a high-tech craft. They wouldn't know how to make the metal, but they might try to replicate that sacred shape in the only material they knew, stone. Whether it's a relic of a lost machine or a tribute to a forgotten science, the Sabu disk remains a smoking gun of a technology that, by all accounts, should not exist. If you ever find yourself in London, at the University College, there is a small, unassuming artifact tucked away in the Petrie Museum that might be the most important piece of evidence ever recovered from Egypt. It isn't made of gold. It isn't covered in royal hieroglyphs. It is simply a small, tapered cylinder of pink rose granite, barely a few inches long. It is known to history as Granite Core No. 7. It was discovered in Giza by Sir William Flinders Petrie, the man often called the father of modern archaeology. Now, Petrie wasn't a dreamer or a conspiracy theorist. He was a man of cold, hard measurements. He was the first person to truly survey the pyramids with mathematical precision. And when he picked up this specific core, he realized he was holding a physical impossibility. You see, a core is the waste product of a tube drill. When you drill into stone with a hollow pipe, the centerpiece stays inside. That's the core. But when Petrie examined Core 7 under a magnifying glass, he found something that defied the laws of primitive tools. There was a continuous, uniform spiral groove etched into the granite, running from the top of the core all the way to the bottom. It looked exactly like the threads on a modern screw. Now, why does a spiral groove matter so much? Because in engineering, the distance between those grooves tells us the feed rate of the drill. Petrie took his micrometers and measured the distance. He found that the drill was sinking into solid rose granite, one of the hardest stones on Earth, at a rate of 1/10 of an inch for every single revolution of the drill. Let that sink in for a moment. To put that in perspective, if you take a modern, high-speed steel drill today and try to penetrate granite, you wouldn't get anywhere near that depth per turn. Petrie himself, who was a very conservative scientist, calculated that to achieve this kind of bite into the rock, the drill would need to have at least 2 tons of pressure pushing it down, combined with a rotational speed that we usually only see in heavy industrial machinery. The official story tells us that the pyramid builders used copper tubes and loose sand as an abrasive. But there's a massive technical problem with that theory. Abrasive sand creates random, messy scratches. It wears the stone down slowly. It cannot, by the laws of physics, create a single, deep, continuous spiral thread that cuts through both the soft quartz and the much harder feldspar crystals in the granite with equal ease. To do that, you need a fixed-point cutting tool, something like a diamond or a jewel-tipped bit, that is significantly harder than the granite itself. But the Egyptians didn't have diamonds in their toolkits. They didn't even have hardened steel. So how did they do it? When you look at Core 7, you aren't looking at the work of a man with a copper pipe and some wet sand. You're looking at the fingerprint of a high-speed precision power tool. You're looking at a technology that could penetrate granite as if it were soft wood. Core 7 is the smoking gun of a machine age that, according to our history books, didn't exist for another 4,000 years. It is a silent witness to a level of engineering that we are only just beginning to understand. Now, we need to go underground. About 30 feet beneath the sands of Saqqara, there is a labyrinth of tunnels carved directly into the limestone bedrock. This is the Serapeum. And inside these dark, narrow corridors lie 24 massive granite boxes that defy every rule of ancient construction. Each of these boxes, and their lids, is carved from a single block of solid Aswan granite. They weigh between 70 and 100 tons each. To give you an idea of that scale, that's equivalent to about 50 modern SUVs stacked on top of each other. But the weight isn't even the most shocking part. The real mystery is the precision. In the 1990s, master craftsman and engineer Christopher Dunn entered these tunnels with industrial-grade measuring tools, the kind used in aerospace manufacturing. He placed a precision machinist's square against the interior surfaces of the boxes. What he found was staggering. The surfaces were perfectly flat to within a few 10,000ths of an inch. That's a level of flatness we usually only see on modern granite surface plates used in high-end laboratories. The corners were even more impossible. They were perfectly 90 degrees, not just close, but mathematically exact. To achieve this in solid granite, you can't just rub it with sand and water. You need high-speed machining. You need tools that can maintain a perfect axis while cutting through one of the hardest materials on our planet. Then, there's the logistics nightmare. The tunnels of the Serapeum are barely wider than the boxes themselves. There's no room for hundreds of slaves to stand on either side and pull ropes. There's no room for massive wooden rollers. How did a primitive culture move 100-ton objects into a cramped underground tunnel and then place them into recessed chambers with such surgical precision? And here's the detail that mainstream history often ignores. There is no soot on the ceilings. In a dark, oxygen-deprived tunnel, you would need thousands of torches to see what you were doing. Torches leave carbon deposits. But the ceilings of the Serapeum are clean. This suggests they weren't using fire for light. They were using something else. Mainstream Egyptology tells us these were coffins for sacred Apis bulls. But when they were first opened, they were empty. No mummies, no bones, just air. Why spend decades of labor and utilize industrial-level technology to create perfectly sealed, vacuum-tight granite boxes for nothing? The Serapeum isn't a cemetery. It's an abandoned power plant or a high-tech storage facility. It is a place where stone was treated like plastic, and where the laws of physics as we know them seem to have been bypassed by a technology we are still trying to rediscover. Once you see this next detail, you will never be able to unsee it. If you walk around the base of the Pyramid of Menkaure in Giza, or look closely at the granite casing stones of the Great Pyramid, you'll notice something incredibly strange. On the faces of these multi-ton blocks, there are small, protruding nubs or knobs left on the surface. They look like little handles or bumps that weren't sanded down. At first glance, you might think they were just unfinished work, but as you dig deeper, the mystery takes a global turn. These exact same knobs, with the same shape, size, and placement, appear on megalithic walls 7,000 miles away in Peru, at the massive fortress of Sacsayhuaman and the Sun Temple of Ollantaytambo. You find them in Turkey, in Greece, and even on Easter Island. Why would builders on different continents, separated by thousands of years and vast oceans, leave the same peculiar marks on their stones? Mainstream archaeologists suggest these knobs were used as lifting points, places to attach ropes or levers to move the stones. But that theory falls apart when you look at the physics. Some of these knobs are at the very bottom of the stones. Others are so small and fragile that if you tried to lift a 20-ton granite block with them, they would snap off instantly. So, if they weren't for lifting, what were they? Engineers and alternative researchers have a much more radical theory: the softening of stone. When you look at these knobs, they don't look like they were carved out of the rock. They look like they were squeezed out, as if the stone was temporarily in a plastic or clay-like state. Imagine a giant machine pressing against a block of granite that has been softened by heat, vibration, or a chemical catalyst. The knob is the residue, the part where the material was forced out of a mold or a pressure point. Think about the implications. If the ancient builders had the technology to soften granite, one of the hardest stones on the planet, it would explain everything. It would explain how they achieved such perfect laser-thin joins. It would explain how they carved those complex 90-degree interior corners we saw in the Serapeum. These knobs are like the trademark of a specific type of high-tech construction. They are the leftovers of a process we don't yet understand. It's as if a single architectural ghost traveled the world, teaching a very specific method of advanced masonry that used stone not as a brittle solid, but as a moldable material. Are we looking at the remnants of a global technology that existed long before the dawn of our recorded history? The knobs are a silent yes. They are the physical evidence that someone, somewhere, knew a secret about matter that we have completely forgotten. In 1858, an archaeologist named Auguste Mariette found a limestone tablet buried in the sand near the Temple of Isis, right next to the Great Pyramid. This artifact is known as the Inventory Stela. On the surface, it looks like a simple list of statues and repairs made by the pharaoh Khufu, the man we are told built the Great Pyramid. But when scholars translated the text, they found something that threatened to burn every history book in the world. According to the stela, Khufu didn't build the Great Pyramid or the Sphinx. It claims that when Khufu arrived at Giza, the Sphinx was already ancient, and its tail and head were being swallowed by the sand. The text literally says, "He found the house of Isis, mistress of the pyramid, beside the house of the Sphinx." Do you see the problem? If Khufu was the builder of the pyramid, how could he find a temple beside it that was already standing? And why would he be restoring the Sphinx if his own son, Khafre, was supposedly the one who built it years later? For decades, mainstream Egyptologists have dismissed the Inventory Stela as a forgery or a pious fiction created by later priests to give their temple more prestige. They say the style of the writing is too modern for Khufu's time. But while the historians were arguing about the text, the geologists were looking at the rocks. In the 1990s, Dr. Robert Schoch, a geologist from Boston University, conducted a detailed study of the Sphinx enclosure. He pointed out something undeniable. The Sphinx and the walls surrounding it are covered in deep, vertical fissures. In geology, this specific type of erosion is caused by one thing only: heavy, prolonged, torrential rainfall. Here's the bombshell. Egypt has been a bone-dry desert for at least 5,000 years. The last time there was enough rain in Giza to cause that kind of erosion was at the end of the last ice age, somewhere between 9,000 and 12,000 years ago. This means the Sphinx wasn't built by a Bronze Age pharaoh. It was carved by a civilization that existed when the Sahara was a lush green jungle. The Inventory Stela isn't a fake. It's a testimony. It's a record from a pharaoh who was trying to preserve a legacy that was already thousands of years old when he found it. If the Sphinx is 12,000 years old, then the technological ghost we've been looking for isn't just a theory. It's a historical fact that has been staring us in the face for millennia. We've been attributing the greatest wonders of the world to the people who inherited them, rather than the people who actually built them. To understand the true scale of the mystery, we have to travel south to the granite quarries of Aswan. There, lying half-finished in the bedrock, is a giant that never stood up. It's called the unfinished obelisk. If it had been completed, it would have been the largest single piece of stone ever handled by human hands, standing 137 feet tall and weighing a staggering 1,200 tons. To put that in perspective, 1,200 tons is the weight of about 3 Boeing 747s. Mainstream history tells us this massive monument was being carved out for Queen Hatshepsut using nothing but dolerite pounders. Dolerite is a stone slightly harder than granite. The theory is that hundreds of workers stood in narrow trenches, day after day, smashing these stone balls against the granite to wear it away. But when you actually stand in the trench next to the obelisk, that theory starts to crumble. Look at the walls of the trench. They aren't covered in the jagged, uneven marks of a hammer or a chisel. Instead, they are covered in long, smooth, repetitive scoops. It looks exactly like someone took a giant ice cream scooper and carved through the solid granite as if it were soft butter. There is a rhythm to these marks. They are uniform, wide, and they transition from the vertical walls to the horizontal floor in a continuous curve. If you were using a stone ball to pound the rock, you would get a crushed, dusty surface. You would not get these clean, flowing troughs. And then there's the human problem. The trench is incredibly narrow, barely 2 feet wide. If you had hundreds of workers in there, they wouldn't even have enough room to swing their arms to generate the force needed to break granite. The heat in Aswan can reach 120 degrees Fahrenheit. The dust would be suffocating. It is a logistical and biological impossibility. So, what are we actually looking at? Engineers who visit the site often point to a different possibility: thermal or ultrasonic machining. The scoop marks look like the result of a tool that could either vibrate at a high frequency or generate intense heat to soften or vaporize the rock in a specific path. It looks like a machine was moved across the surface, excavating the granite in precise passes. The obelisk was abandoned because a massive crack developed in the stone. But the mystery isn't why they stopped, it's how they started. If we can't explain how they made the trench, how could we possibly explain how they intended to lift a 1,200-ton monolith out of a hole and transport it hundreds of miles down the Nile? The unfinished obelisk isn't just a failed project. It's a crime scene of an ancient, high-energy technology that we are still unable to replicate today. Deep within the Temple of Ctesiphons at Abydos, one of the most sacred sites in ancient Egypt, there is a lintel stone that has sparked more debate than perhaps any other carving in history. High up on a ceiling beam, there is a set of hieroglyphs that, to any modern eye, look disturbingly familiar. There is an image that looks exactly like a modern attack helicopter, complete with a rotor blade and a tail fin. Next to it, an icon that resembles a heavy tank or an armored vehicle. And just below, a shape that looks like a sleek, supersonic jet or a specialized glider. When photos of these carvings first hit the internet in the 1990s, they went viral instantly. People claimed this was definitive proof that the ancient Egyptians had contact with high-tech flying machines, or perhaps even time travelers. But if you ask a mainstream Egyptologist, they will tell you there's a perfectly logical, albeit complex, explanation. It's called a palimpsest. In ancient Egypt, it was common for a pharaoh to appropriate the monuments of his predecessors. This specific lintel was originally carved during the reign of Seti I. After he died, his son, Ramesses II, decided to replace his father's name with his own. The royal scribes filled in the old carvings with plaster and carved the new titles on top. Over thousands of years, the plaster crumbled away, leaving a bizarre overlap of 2 different sets of hieroglyphs. According to the official diagrams, the helicopter is actually the result of a Who Subdues the Nine Bows title, overlapping with a Who Protects Egypt title. On paper, the math seems to work. The shapes do align. Case closed, right? Well, not quite. Even if we accept the palimpsest theory, we are still left with a staggering statistical impossibility. Out of the millions of hieroglyphs carved across Egypt, why did this one specific overlap, in this one specific temple, create 3 distinct modern military vehicles? If you overlap 2 random sentences in English, you usually get a messy, illegible scribble. You don't get a perfect silhouette of a Boeing 747. And then there's the Saqqara bird, a small wooden object found in a tomb in 1898 that looks like a high-performance glider. When engineers tested the Saqqara bird's proportions in wind tunnels, they found it was aerodynamically sound. So we have to ask a deeper question. Is it possible that the scribes at Abydos didn't just make a mistake? Could they have been visually influenced by a subconscious memory of machines that once filled the skies? Were they trying to encode a lost history into the very names of their kings? Whether it's a freak coincidence of overlapping stone or a hidden message from the past, the Abydos helicopter remains a haunting reminder. Sometimes the errors of history are more revealing than the facts themselves. Right next to the eastern face of the Great Pyramid of Giza lies a massive dark floor made of black basalt. Most tourists walk right over it without a second thought. But for an engineer, this pavement is a gold mine of forbidden technology. Basalt is one of the hardest stones available. On the Mohs scale, it's significantly tougher than the limestone used for the pyramid's core. To cut it, you need immense force. And when you look closely at the edges of these blocks, you don't see the irregular marks of a hand chisel. You see something far more industrial. On several blocks, there are clear, curved striations, deep parallel grooves that could only be made by one thing, a massive circular saw. Now look at the radius of these curves. By calculating the arc of the saw marks, engineers have estimated that the blade used to cut these stones was at least 6 to 10 feet in diameter. Imagine a circular saw the height of a basketball hoop, spinning at high speed, slicing through volcanic rock as if it were plywood. But the mystery goes even deeper. As the saw cut through the rock, it left step marks where the blade was stopped and then restarted. These marks show that the blade was moving through the stone at an incredibly high feed rate, meaning it wasn't just grinding away slowly over months. It was biting deep into the basalt with every rotation. To power a blade that large, through stone that hard, you need more than just manpower. You need a massive amount of torque and a stable energy source. You need an engine. Sir William Flinders Petrie, whom we mentioned earlier, noticed these marks back in the 1880s. He was so shocked by them that he wrote in his journals that the pyramid builders must have had tools that we are only just beginning to reinvent. He even suggested they used diamond-tipped saws, because nothing else could leave such clean, sharp cuts in basalt. But according to our history books, the Egyptians of the 4th dynasty didn't have hardened steel to make a blade that large, let alone diamonds to tip it with. They were supposed to be using copper, which is a soft metal. Trying to cut basalt with a copper saw is like trying to cut a steak with a wet noodle. It's physically impossible. These saw marks are the fingerprints of a high-tech construction site. They tell us that 4,500 years ago, the Giza Plateau wasn't just a place of prayer and tombs. It was an industrial zone, filled with the scream of high-speed blades and the hum of machines that, by all rights, should not have existed for another 4 millennia. For our final mystery, we aren't looking at 1,000-ton blocks, but at something you could hold in your hand. Beneath the step pyramid of Djoser, archaeologists discovered something breathtaking. Over 40,000 stone vessels, many of them dating back to the pre-dynastic era, long before the pyramids were even built. But these aren't your typical clay pots. They are made from some of the hardest materials on Earth: diorite, schist, and translucent quartz. When you examine these vases, the level of precision is honestly terrifying. Some have necks so long and narrow that a human finger can't even fit inside, yet the interior is perfectly hollowed out. Even the shoulders of the vase are paper-thin and uniform in thickness all the way around. If you were carving this by hand with a chisel, it would be impossible. The moment you hit the interior wall, the vibration would shatter the brittle stone. Modern engineers have placed these vases on high-precision lathes and found that they are perfectly balanced. The symmetry is so exact that it suggests they were turned on a machine. Not a foot-powered pottery wheel, but a high-speed, fixed-axis lathe. Look at this specific vase, made of diorite. Diorite is so hard that modern granite cutters use diamond tools to shape it. Yet the ancient makers managed to leave a surface finish as smooth as glass. Even more baffling, some of these vases feature undercutting, where the inside is wider than the opening at the top. To achieve this, you need a tool that can expand once it's inside the neck, or a flexible cutting head that maintains constant pressure while spinning at thousands of revolutions per minute. This is CNC-level precision, thousands of years before the invention of the steam engine. Why would a primitive society invest so much energy into making thousands of perfect stone jars? They didn't even have iron tools, yet they were mass-producing precision-engineered containers that we struggle to replicate today. These vases are the ultimate proof that the technological ghost wasn't just about big buildings. They were masters of the small scale too. They possessed a deep, fundamental understanding of material science and rotational mechanics. When you hold one of these vases, you aren't just holding a vessel. You are holding a piece of hardware from a forgotten industrial age, a silent witness to a time when humans or someone else mastered the very atoms of the earth. 9 technologies, 9 signatures of a world that shouldn't exist. From the high-speed drills of Giza to the precision vases of Saqqara, the evidence is carved in stone. Literally. We can no longer look at these artifacts and say they were made by chance or primitive persistence. The math doesn't allow it. The physics doesn't support it. We are looking at the remnants of a high-tech civilization that was wiped from the map, leaving only their most indestructible monuments behind. This is the takeaway. History is not a straight line. It is a cycle of rising and falling. And if we want to understand our future, we must first be brave enough to admit that we don't fully understand our past. These stones aren't just ruins. They are a challenge. A challenge to keep looking, keep questioning, and never assume the story is finished. Because the most incredible discovery might still be waiting under the sand. From the precision of pre-Egyptian lost artifacts to the self-healing concrete of Rome, history proves that our ancestors possessed a brilliance we are only beginning to rediscover. These weren't just buildings or tools. They were messages left in stone, challenging us to rethink our own future. If they could build for eternity using only the elements of the earth, what have we lost in our pursuit of the modern world? Perhaps the key to our future doesn't lie in new inventions, but in the forgotten shadows of the past. Thank you for watching this journey through time. If you're fascinated by the mysteries of the ancient world, don't forget to like, subscribe, and let us know in the comments. Which ancient technology do you think is the most impossible?